class. So today we're going to be looking at GPS 8, which is solving linear inequalities. So inequalities are basically these symbols. So I'm sure you've seen these symbols before in the past. So this is the greater than symbol. Okay. Um, oopsie. So let's go back. So yeah, this is that's the greater than symbol. This one is the greater than or equal to symbol. This one is called the less than symbol. And this one is called the less than or equal to symbol. So if you have a line underneath the inequality, that means that it could be equal to. So there's so you'll notice that the greater than and the less than, all right, and the greater than or equal to and the greater than less than, the difference is basically one group of them have a line underneath, the other one does not. So they're separated into two different categories. So we have the exclusive, okay, and then we have the inclusive. We have the exclusive and then we have the inclusive. So exclusive means that we don't include the endpoint. So exclusive would be these inequalities, the less than inequality and the greater than inequality. And we use a open circle to represent them. The inclusive category includes the less than or equal to symbol and the greater than or equal to symbol. So the ones with the line underneath them are inclusive, means we include the endpoint, and we use a closed circle to represent them. Okay, so keep that in mind. Exclusive, all right, means we don't include. Those are the symbols that we use, and we use an open circle. Inclusive, those are the symbols that we use with the line underneath, and we use a closed circle. All right, so if you forget, look back at this slide for reference. So let's look at an example. Let's just go over these. So here, okay, remember, think of this little Pac-Man or like the less than sign, right? Think of it as like a Pac-Man, okay? He always eats the bigger number. So this Pac-Man guy, or the alligator, I like to call him alligator, right? He gives him some teeth, he's like alligator. Like, alligator. He's like a alligator over here. Okay, so he always likes to eat the bigger numbers. He don't like the small ones. He likes to eat the big ones, and he'll always point. He points to the small ones. Okay, so for example, it'll be like 5, and then so he's eating the 5 because 5 is bigger than 2. He points at the 2 and he eats the 5. 5 is bigger, 2 is smaller. So if we look at it in terms of variables, right, we have, so you always read it in terms of x. So we have less than x, right? So it's pointing at the x. So if it's pointing at the x, that tells us that x will be smaller. And since there's no line underneath, this is an exclusive. If it's exclusive, we use an open circle, right? Always look back here for reference, right? See, exclusive does not have the line underneath, and we use open circle. So that's why here we have an open circle, okay? And then it's pointing at the x, so x is smaller. So where is x smaller? On a number line, right? On a number line, everything to the left is smaller, right? Everything to the right side is bigger. So if you want bigger, you would shade to the right. If you want smaller, you would shade to the left. So let's look at another example. Now in this example, you see how the less than sign has a line underneath it? If it has a line underneath it, then that means it is inclusive, right? It's inclusive. And if it's inclusive, we use a closed circle. Okay, so if it has a line underneath, we use a closed circle. This one has a line underneath the inequality, so it's a closed circle. So as you can see, we have a closed circle here, or filled in circle. And remember, you read it in the x's perspective. So we see the inequality is eating the x, right? Inequality eats the x, so that means x is bigger. So which way is x bigger? To the left or to the right? Remember we mentioned all the numbers to the right are bigger, so therefore you shade to the right side. Okay, so let's look at some other examples. Okay, let's look at this example. So you can kind of skip all this other wording, a lot of words. You skip all that. Right, let's just focus on this. and our number line here. So we have x is greater than 1. All right. So again, since there's no line underneath, this is exclusive. So we're going to use a open circle, right? No line underneath, it's exclusive. We're going to use an open circle at 1. So at 1, we have an open circle. And now the inequality is eating the x. So if the inequality eats the x, that means x is bigger. Which way is x bigger? To the right or to the left? It's going to be to the right. Okay, it's eating the x, so x is bigger. So we shade to the right. All right, let's look at another one. Again, you can kind of skip all this mumbo jumbo here. Okay, skip all this. If you have time, you can read it, but let's just go straight to problem. So we're just going to focus on this guy here. So it's -1 greater than or equal to x. So we have -1 greater than or equal to x. Now, this one has a line underneath. Since it has a line underneath, it is inclusive. So we're going to use a closed circle at -1. So at -1, we have a closed, oopsie. -1, we have a closed circle. And the inequality is, well, what's it doing to the x? The inequality is pointing at the x, right? Remember, you always read it in terms of the x. What's the inequality doing to the x? This inequality is pointing at the x. So that means that x is going to be smaller. So since it's pointing at the x, x is smaller. Which way is x smaller on the number line? Everything to the left. Okay, because it's pointing at the x, so x is smaller, so you shade to the left. Let's look at another one. Okay, so here we're going to learn how to solve some equations. So, I mean, let's just skip all of this, words, skip all this stuff. Let's just take the equation. 3x minus 7 greater than 5. Okay, 3x minus 7 greater than 5. Okay. So we have 3x minus 7 is greater than 5. Wait, let me just double check that. 3x minus 7 greater than 5. Okay. So we have 3x minus 7 is greater than 5. So the way we solve inequalities is you solve an inequality just like how you would solve a normal equation. So how would you solve a normal equation? What would you do? Right, pretend that's an equal sign. So what would you do? You would plus 7 to both sides, wouldn't you? Right, you want to isolate the x. You get plus 7 to both sides. 7 cancels out. We're left with 3x is greater than, and then 5 plus 7 is 12. Divide both sides by 3. So then x is greater than 4. Right? So now we're going to graph down the number line. So since it doesn't have the line underneath, all right, we're going to use a open circle at 4. And then remember, the inequality is eating the x, so that means x is bigger. So which way is x bigger? To the right. Okay, well, that's our solution, right? All right, let's do another one. Okay, so same thing. We want to solve this equation, all right? So we have -4 greater than 5x plus 6. So how do I solve this equation? You want to get x alone, so let's minus 6 to both sides. That cancels out. We're going to get -10 greater than 5x. Divide both sides by 5. Divide both sides by 5. So that's -2 greater than x. Okay, so that is our solution inequality. And since this inequality does not have the line underneath it, it's an open circle at -2. So open circle at -2. And the inequality is pointing at the x, so that means x will be smaller. So we're going to shade to the left. Okay. The next one, we have 6x plus 2 greater than or equal to 20. So again, solve it like a normal equation. -2 to both sides. That cancels out. We get 6x is greater than or equal to 15. Divide both sides by 6. So x is greater than or equal to 3. Okay, that's our solution. Put that in the box. And since this inequality has the line underneath, this is a closed circle. It's inclusive. So closed circle at 3. So at 3, we're going to have a closed circle. And the inequality is eating the x. So if the inequality eats the x, that means x will be bigger. So that means I got to shade right where the number is bigger. Everything to the right side. Okay, and that's it. So one thing I want to mention is that as you can see, we solve inequalities just like normal equations, okay? Except there is one exception. So let's write that down. So we solve inequalities like normal equations with one exception. Okay, one exception. So what's the one exception? The one exception is that when we multiply or divide by a negative, okay, multiply or divide by a negative number, all right, we switch the inequality. Okay, so I'll show you in the next GPS what I mean by that, okay? And only when you divide by a negative number do we switch the inequality, or we flip the inequality, whatever you want to call it. All right, so again, if you have any questions, you can replay the video, watch it again, or post a question on the discussion forum. See you next time.